I'm going to start now with my presentation, and we have a new feature, or we have several new features in Omnis Studio 10. One of them is the possibility to remotely debug your code, and I'm going to demonstrate that now. So I don't think that I need to explain in detail what remote debugging is. Well, the picture shows it quite well. Right? Remote debugging allows you to, to remotely debug Omnis code, to test and debug your Omnis code, which is running on another PC. And maybe you all know, or you probably all know, the situation where your customer calls in and says something doesn't work, and you can now, or you now have the feature to use your Omnis development environment and remotely debug the application of the customer system, which can save you a lot of time. You don't have to drive to your customer, you don't have to install Omnis environment there, and you don't have to call the support as well. So it also saves me probably some effort. The remote debugger in Omnis is a read-only interface. It allows to view your code, to set breakpoints. You can step through the code, you can step into methods, and you can view and change variables. How does it work? You use a development edition, Studio 10 development edition, to access another copy of Omnis, which can be an Omnis Studio 10 server or an Omnis Studio 10 headless server running on Linux, for example, over the network, over the internet, and you can also debug your runtime, your fat client applications if you want to, and you could also debug the Omnis Studio 10 development environment itself if you want to. And of course the application is running inside of these installations. Your application is running there. And we call it, or a connection between Remote Debug Client and Remote Debug Server, we call it Remote Debug Session. Remote Debug Client and Server can be on different operating systems, so you could use your Mac to debug an application or an Omnis Studio copy that is running on other platforms like Linux, Windows, or Mac as well. Or you could use your Windows PC, an Omnis installation, to debug on Linux, Windows, Mac OS X as well. It's up to you. Remote debugging doesn't work by default. You need to modify the remote debug property of your library and set it to true. In addition, you need to change the remote debug property of the task instance. So you could change the property for your main library, maybe for the startup task, and you can as well change this property for your remote task if you have a JavaScript application. And in addition, you could also use a URL parameter, which is called Omnis Remote Debug, and then of course you don't have to set it here in the library. So you can simply add it to the URL which is accessing your remote form. What can you remotely debug of course, you can debug unprotected libraries and unlocked classes, but you can also remotely debug locked libraries and libraries that are set to be always private. Yeah, that would also work. And you can, in addition, debug Omnis code that is running on a multi-threaded server, which cannot be done in the local debugger. That would also be possible using the remote debug functionality. A few words about the connectivity. The remote debug line is a WebSocket. The WebSocket will be provided by another feature in Omnis Studio 10, the Node.js server, which is running inside your Omnis installation, and it's a direct connection over a specific port, so you might need to enable the port in your firewall. And the connection itself is via HTTPS, and you can use a certificate if you want to make it even more secure. Remote debug server and client are completely integrated into Omnis, so you don't need to install any additional tools. The remote debug server can be configured via a window. You can see here, this is an Omnis Studio runtime, and you have a menu called Remote Debug, where you can manage the Remote Debug server and enter your parameters. And you could also use an Omnis Development Edition as a Remote Debug server if you want to. And as you can see, you actually get the same window here display where you can enter the parameters. And if your application is running on a Linux headless server where you don't have any visible control interface, then you can control it over a browser, and we have a certain HTML font that you can use. And of course, the parameters you specify here are identical to the runtime and your Omnis development environment. What do you need to enter into this window? The debug port, of course. I think you can't read it. This is just the number that we specify here. This is the port where the remote debug server is listening for the client, for the remote debug client. Then you can specify a certificate here if you want to. Password, of course. A list of trusted certificate authorities certificates. If you want the client, or if you want to use the client certificate as well, then you would need to specify it here. Then you can use, or you can enter the username and the password for this remote debug session here, and there are startup options. It's quite small. This means start remote debug server at startup, which is clear, I think. And then there's pause execution at startup option. If this is enabled, then Omnis waits until the client connects, waits until the startup task of your libraries will be executed. Only if a remote debug client connects, then the startup task of your libraries will be executed. These settings will be saved in a file which is called Remote Debug Server Config. It's a JSON file and it's inside your Omnis installation. If you want to, you could edit it manually as well. The Remote Debug Client is a new tool in your Omnis Studio 10 Development Edition. it can be accessed here on the left side in the remote debug client, and here you can then create new sessions, remote debug sessions, and open these sessions. And of course, you need to enter the details you have specified on the remote debug server.
I can hardly hear you when you talk to the screen.
Excuse me, it's always the same. My problem, sorry. So now I'm sitting here directly, then you can go. Okay, I will now demonstrate that live. I have prepared a Linux headless server. Not a Linux headless server, a Linux server, where a Omnis headless server is running. Inside it is inside a virtual machine here on my PC that I'm now going to start. The Linux, or the Omnis Linux headless server doesn't have it's invisible, yeah? It's just a process which is running. You don't have a visible Omnis environment that you can control. You can control the Omnis Linux headless server here via a remote form that you can see here, and it's quite small, I think. I've already prepared a library and opened it here inside the Linux headless server. And there is, where is it? When you go to settings, then you have a tab here which is called Remote Debug. There are two tabs. One is to control the server, to start and stop the debug server, and the other you have seen in the presentation. Here you can enter the details. For example, I have set it to port 5998. I don't use any certificates here, just a plain connection. Okay, let's start the remote debug server. It's now listening for incoming connections from the Omnis development environment from the client. And the remote debug client can be set up here on the left side. You can here have a look at the session manager. I have already prepared a few sessions, and I could enter a new remote debug session here. What I'm now going to do, let's call it, give it a name, let's say headless test. Oops. I then need to enter the port. Port was 5998. Not here, of course, here. And we need to enter the IP address of the PC or computer where the remote debug server is running. And it's here inside the little machine, so I need to find out the IP address of this little machine. .pconfig.
So you can't use domain names?
I can, but I don't have a domain name here. But you can, yeah. Yes, this is my little machine here, and the IP address would be this one, which is, okay, let me enter it. 192. Yeah, okay. So I don't use any certificates, I just need to enter the username and password twice, save it, and then I can here click on back and open the new remote debug session here, and I am now directly connected to the Linux headless server, to the Omnis Linux headless server, and as you can see, there is my library, and you can then browse through your library. All classes are listed here. You can browse into the folder. Okay, there isn't any class in, but there should be, I think. code classes will not be listed because there is no code inside. But I could, of course, click here, for example, on the remote form, and then the remote debug window opens, and it looks quite similar to the local debugger that you know, right? So on the left side, you will find your methods that you have in your remote form or in other classes. You will find the controls here on the left side, each one with its $event method. And on the upper area there, you will notice that there is the variable panel missing, right? Which you have in the local debugger. Therefore, you have this panel here on the lower right side where your variables will be displayed. But I need, of course, an instance first. So I can now set a breakpoint, let's say behind the button here, as you would do it in your local debugger. And then I need an instance, of course. So let's try that. Forgot the IP address. This one. And I think I need to find out the web server port first. That should be here, which is 5912. And then I'm connecting directly or using the Omnis built-in web server here. So I'm SCHML/ and there's a remote form JS remote 1, I think, HTML. So try that. So this is my remote form. It's displaying the form inside my library. There is a button, 2 fields, nothing more. And I have, first, and of course, I need to reconnect here, and then I can check if the breakpoint is still there. No, it is not. So let's set it again. Refresh again, and when I now click, yeah, now it works. You can see that Omnis wants to come to front. You can't see that Omnis wants to come to front. And we are now here remotely on the Omnis Linux header server inside or behind the button. And you can see here the go point. And we could now use, as you know from your local debugger, these buttons here to step in to this method, for example. Or the method stack is listed here. You could also have a look at the method stack here, of course. Let's have a look at the, as I said, the variable panel is missing, and important is that you need to have a look here at the lower right side. So let's try that with a simple data type like character variable. I assign a value to this character variable, and I'm not sure if you can see that. Maybe I could increase the font a little bit here. Worker fields. Not sure. You will find all your variables here in this area. As you can see, different scope, class, instance variable, local, parameters, event parameters, the file classes, and even the hash variables are listed here.
Hash 52.
Hash 52.
That's an important one.
Of course. Okay. So you could also use the keyboard to navigate through this area. So if I click here on the C, then it will jump to the class methods. Yeah. So you don't have to use the mouse. So as you can see here now, I've assigned a value debug anywhere to this character variable, and it's displayed here. And I could, if I want to, I could modify this value here. Let's remove that and save it back. There's another small button here that you can use to toggle the between null and empty. So when I click here, you can see that the variable now is null and empty, and of course I could re-enter the new value.
Corrector.
So let's try it with a little bit more text here. Press go, and as you can see now there are more than 1,000 characters now inside my variable, and this of course cannot be displayed fully here in this small area. So I can click on this area and it now drills down into the variable, and I can see the full text. If the variable contains more than 64 kilobytes, then these next and previous buttons will be enabled, and we could then step through the text. So let's have a look at other variable types. I forgot to say the type of the variable is of course displayed here in this area. So now I'm going to create a list with, maybe I could even increase the font here a little bit, you can see better. Wrong one.
That was the wrong one.
No, general face tree. Oh, should be this one, right?
Try every.
Okay,
There we go.
okay. I create a list with more with 100 lines here. Click on go, and you can see now here iList has exactly 100 lines, and I could again click here inside the or on my variable, and then it drills down, and you can see all the lines that are in the code. But as you can see, not 100 lines are displayed. If you want to have a display all, if you want to display all, then you click here. Can you click here on the next button, and Omnis will load the rest. What's interesting here as well is that you could, here it is, set the current line. So if you want to set, let's say you want to have the second line current, then you can enter it here, and you can see now this line is then current, and you could also here set the select state of a line. Let's say we want to have line 1 to 5 to be selected, then you enter it here, and they will be selected. Another interesting feature here is that you could add conditional breakpoints. Let's say you have a loop with 100 loop which runs 100 times. You want to stop the code inside the loop for whatever reason, and when the counter here has a value of 15, yeah, let's say, but you don't want to, of course, don't want to click on the go point here 50 times. So you maybe let's first reset the list variable to empty, and where is it? The counter, and set it back to 0, and set the go point back here. You've now got the option.
Wait a sec. You need to execute the define as well, because you emptied the list.
I don't think so.
Ah, okay.
It should be working.
Okay.
I tried it in a German session and it worked. Yeah, so.
Okay, sorry.
Okay, but thanks. Where is it? First I need to set a breakpoint here inside the loop, and then I've got the option here to set a condition. So let's say we want to stop inside the loop when the counter is 50. Now I can click on go, and it stops. As you can see here, when the loop or the code has been executed 50 times. Yeah, and if we have a look here at the variable, you can see it's okay. It contains 49 lines now. Okay. So I have two other types of variables here. One would be an object variable, which is here a timer. Let's try that. I can step in to the timer object instance here into the construct. I calculate here a text variable. I can set, or a few properties will be set. Use seconds, click true, timer going to 5 seconds. And let's have a look at the object. So yeah, if you click on it, it drills down again. You can here check your instance task and class variables inside the object instance, and you can as well change a few properties here if you want to. Yeah, you could change the timer value to 10 seconds, yeah. Or just set here use seconds to give false, for example. And the last variable type here would be a binary variable here. No, where is it? Where is it? I've been here. What I'm doing here is to read a file from the system into the binary variable, and we can again click here on this binary variable, and you can then check the contents here. You could even, if you want to, you could even modify the binary value here, so we could, let's say, I don't know the hex values here, but you can change it, save it. Yeah, now it's a bug. It's not debug, it's a bug now. Okay. So I'm not sure how much time is left.